Okay, so now that we discuss on Newton's first law iaitu inertia and Newton's second law iaitu F equals to ma, so kita akan tengok pula Newton's third law. Okay, so before this I only emphasize Newton first and second law sebab mainly calculation revolve around that lah, two laws kan. Tapi Newton third law ni adalah konsep, so jarang ada calculation. Cuma Miss nak emphasize lah. Okay, so Newton's third law, okay, dia cakap apa dia cakap, okay, dia cakap for every action force, okay, action maksudnya apa yang kita berikan force, has a reaction. Reaction ni apa? Reaksi dia lah. Okay, so that is equal in magnitude, nilai dia sama tapi in opposite direction. Okay, so ni memang secara semula jadi ni happen yang real life. Okay, so contoh yang kamu boleh nampak adalah kamu berdiri. Okay, contohnya macam, okay, you yourself lah, kamulah kan tengah berjalan. Okay, so kita belajar sebelum ni kan, setiap objek yang ada mass, obviously kamu ada mass, contohnya mass kamu maybe 60 kilogram. Okay, and then you ada weight lah, force weight ke bawah kan, and then you walk on the earth ni kan. Tapi surprisingly, walaupun kamu ada force yang tertarik ke bawah, tapi mana ada kamu jalan-jalan lepas tu kamu tiba-tiba terjatuh ke tengah bumi tu kan. There's no such thing. Okay, sebab apa? Sebab ada something yang counter back you punya force yang tarik you ke bawah, iaitu kita panggil, kalau kita berjalan atas satu surface, kita ada normal force. Okay, okay, so kat sini kita ada action, our weight, and then this is our reaction. Okay, so katalah apa tu, kamu punya weight 60 darab 9.81. Okay, katalah you punya force adalah 588.6N. Okay, so sepatutnya kamu akan jatuh ke bumi ke bawah kan dengan 588.6. Tapi what happen? Tidak, ada normal force yang counter back, di mana nilai dia juga adalah 588.6 Newton. Okay, equal in magnitude but in opposite direction. Okay, satu ke atas, satu ke bawah. Jadi bila kita cari total force kita, okay, atas tolak bawah 588.6 tolak 588.6, kamu dapat kosong. Okay, that's why kamu boleh tak ada nak pergi naik atas lah, tak ada nak pergi ke bawah lah, kamu just total force kamu kosong. Okay, you can just walk on the surface of the earth normally. Okay, so itulah salah satu contoh Newton's third law. Okay, contoh macam kamu push your hands against the wall. Okay, so kalau kamu push the force very high, okay, possible je kamu crack through the wall. Tapi what happen? Normally doesn't lah. Okay, sebab ada, this is your reaction force kamu kasih dekat wall ni, and then ada ni ada action force yang kamu bagi kat wall ni, and then secara semula jadinya ada reaction force yang equal in magnitude, so they cancel each other lah. So whatever, your hand just stay still lah, macam tu. Okay, unless kalau kamu ni very 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 powerful, boleh smash the dinding, tu lain cerita lah. Okay, so contoh salah satu contohnya macam ni, you boleh ada buku, and then dia boleh letak aje macam tu tanpa dia terjatuh ke bawah, sebab ada weight dengan normal ni counterbalance each other. Okay, right, tu and then kamu cuba dengar this abang cakap pasal Newton's law. Okay, this Mak Saleh.
He knows a lot about the science stuff. Professor Dave explains. After learning about Newton's first law of motion regarding inertia, as well as the second law regarding the proportionality of force and acceleration, we are ready to round out the trio and look at Newton's third law of motion. This is most famously stated as follows: for every action, there is an equal and opposite reaction. While this is often quoted out of context for metaphorical purposes, in physics it means something specific and quantitative. It means that if two objects interact, the forces they impart on each other will be equal in magnitude and opposite in direction. Think of a car hitting a brick wall. The car imparts an action force on the wall from its motion, and the wall imparts a reaction force right back on the car, bringing it to a quick stop. These vectors are equal in length and point in opposite directions. What this also means is that there can never be a single isolated force, as any force is an interaction. Forces must always exist in pairs. As you sit in your chair right now, the force of gravity is pulling you down towards the center of the Earth. But something called the normal force points straight up with the same magnitude, which is why you remain perfectly still.